Dear students, in previous video we have learned law of exponents and power, and now in this video we are going to learn square number and square root. First of all, what is a square number? Square number means when a number multiply by itself. Just writing a definition. When a number multiply by itself. By itself means, suppose 2 is there, 2 multiply by 2. 3 is there, 3 multiply by 3. It multiply by itself. We say the number has been squared. The number has been squared and the product is called square, right? Number had been squared and the product is called square number, right? A number multiply by itself. Now see, for example, 2 multiply by 2 is equal to 4. 2 to the 4. Like 6 multiply by 6 is equal to 6 6 ja 36. So these are the number and these are the square of this number, right? Now I'm just going to write some numbers and their squares in sequence. From here I'm going to start. First number is 1. 1 square means power 2 will be equal to 1 multiplied by 1 is equal to 1. See it carefully. All. 2 square is equal to 2 multiplied by 2 equal 4. 3 square is equal to 3 multiplied by 3 equal 9, right? Same. Next, 4 square is equal to 4 multiplied by 4, 16. 5 square is equal to 5 multiplied by 5 is equal to 25. Similarly, 6 square is equal to 6 multiplied by 6 and 6 6 ja 36. 7 square is equal to 7 multiplied by 7 is equal to 7 7 ja 49. And 8 square is equal to 8 multiplied by 8 is equal to 64. And the next I am going to write here 9 square is equal to 9 multiplied by 9 is equal to 81. And 10 square is equal to 10 multiplied by 10 means 100. Done. These are the squares and these are the numbers. Actually these are called square root of the square number, right? And how to denote? This is the sign of square root. Suppose I want to find square root of 4. The square root of 4 is 2. So this will be equal to 2, right? These are called square number. Okay, means finally we can say, if we will take variable here, means a square will be equal to a multiplied by a is equal to again a square, right? So these are the square number. So when a number multiply by itself, we get a square number, right? Now we will talk about some properties. First property we can say a natural number that has 2, 3, 7 and 8 is not a perfect square. Now see, these all are perfect squares, right? 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100. These all are perfect square. Perfect square means when a number multiply by itself, we will get, right? Now see, in these all square, any number, if we will take any number in the world, that will start from these number only, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. Start means at one's place any one of them will come. Any number you may take, one at one's place, any one of them will come. Any one of them means 0, 9, 8, 7, 6, 5, 4, 3, 2 and 1. Now see, when we are getting a square, in square number 1 is coming. See, 2 is not coming in any number. So means 2 is not coming. First property I am going to write here. 3 is coming? No. 3 is also not coming. 4, yes. 5, yes. 7, no. 7 also not coming. Then 8 is also not coming. At one's place only you will see here 6, 5, 6, 9, 4, 1. Don't see 10th place. Only we will see one's place, unit place it is called. So 3, 2, 3, 7 and 8 at one place. See, it is not coming. 0 is coming, but these numbers are not coming. Means 2, 3, 7, 8 never come in a perfect square number. These number never come in a perfect square number, right? Second, if we will leave these numbers, so rest are 1, 4 and 0 also there, 1, 0, 4, 5, 6 and 9. These are number which may come. If they are coming at one's place, it means they are perfect. It means they are a square number. No, it is not essential. It means when these numbers are there at one's place, it may or may not be a perfect square. It may be or may not be, not essential, right? Now next property is a number is ending with an odd number or 0 is never a perfect square. A number is ending with odd number of 0, right? How? Like I'm just writing here. See the number carefully. First number is 10, then 100, then 1000, then 10,000, then 1 lakh. So you may take 2 lakh, 3 lakh, 5 lakh, whatever, but see the number of 0 at the end. How many zeros are there? 1. Here 2, 3, 4, 5. If number of 0 is in odd number, like this number 1 there, in this number 3, in this number 5, these numbers may not be perfect square. These are not perfect square. Okay, so circle 1, these are not perfect square. Whenever 0 will come in odd number, if 0 is in even number, this is also not confirmed this is a perfect square. This may be or may not be. This is not confirmed. Okay, like 100 is a perfect square and the square root of 100 is 10. 10 multiplied by 10 is equal to 100. But I am writing here 200. This is not a perfect square. So it is not essential 2, 0 or even number of 0 will come, it is a perfect square. No. But it may be. Sometime it may be like this. In this one it is given, so it may be. Next property is the square of even number. Even का square and the odd का square. Means square of even number will be even and square of odd number will be odd. Let's take one example for the same. Like even number I am taking 2 square is equal to 4, 6 square is equal to 36, 9 square is equal to 81, and 5 square is equal to 25. Now see, this is a even number, so the square also even. This 6 is even number, so square also even number. This is odd, so square also odd. This is odd, square also odd. It means square of even and odd is odd. This is the next property of the same. The one more property is there. The square of any odd number can be expressed as the sum of two consecutive positive numbers. Right? Let's take new page. See here. Next property is the square of any odd number. Just writing here. Square of any odd number can be expressed as the sum of two consecutive positive numbers. Right? How it is? Let's take one example. Square of any odd number. Any odd number, suppose one odd number is 3 and the square of 3 is 9. So can we express this one in the form of two consecutive? Consecutive means continue. Right? They will come continue in the numbers. So is this is a sum of 4 plus 5 or not? 4 plus 5 equal 9, and this is the square of 3. The next number we can take 5 square. 5 square is equal to 25, and 25 can be expressed in the form of 12 plus 13. 12 plus 13 is equal to 25. So this is the meaning of this property. Means any odd number, any square of odd number can be expressed in the form of sum of two consecutive numbers. Right? Next one is related to the same. Like here 5 square is equal to 25, 3 square is equal to 9. Same, suppose I am taking here n square. Any number we have taken, any natural number. So n square should be equal to, see here, this is 4 plus 5, this is 12 plus 3. It means here also something should be there. So this will be equal to n square minus 1 upon 2, and the second number is n square plus 1 upon 2. This may be expressed out of these two numbers. This one is n square minus 1 and the other one is n square plus 1. This can be expressed in this form. This one, this first form, and this is second form. How can we say this is correct? Let's take one example. LCM of the same. LCM will come, what will come when we will add them? This is the product na. So when, not product, sorry, this is the addition. If we will find addition of the same, 2 is LCM. So what will come? N square minus 1 plus n square plus 1. Minus 1 plus 1, 0. What will come? 2n square upon 2. N square plus n square, 2n square. 2 to 2 cancel. What will come? N square. The same is coming. It means this can be expressed in this form. Which form? N square minus 1 upon 2 and n square plus 1 upon 2. Right? Is it or not? Now next is a perfect square leaves a remainder of 0 or 1 when it divides by 3. Right? Any perfect square. Let me write this one. A perfect square leaves a remainder of 0 or 1 when divided by 3. By 3, right? Let's take example of the same. Perfect square. Whenever perfect square is given, when we will divide it by 3, always remainder will be 0 or 1. Let's perfect squares are, let's write here some perfect square. Perfect square like 4, after that 9 is there, 16 is there, 25, 2 square, 3 square, 4 square and 5 square. These all are perfect square. And let's divide by 3. 4, 3 1 ja 3. What is coming? 1. Now divide it by 3. Now 3 3 ja 9. Remainder is 0. Now this one divide by 3. 16 divide by 3. 3 5 ja 15. What is left? Now see here, remainder is 1. Remainder is 0. Remainder is 1. It means whenever a perfect square divide by 3, the remainder will be 1 or 0. Either 1 or 0. Right? Now next property is, between the squares of two consecutive number, there are 2n non-perfect square. Okay. So in simple words, there are 2n non-square number. There are 2n non-square number between two consecutive perfect स्क्वायर नंबर. ध्यान से समझना इसको, इट इज़ वेरी इंपॉर्टेंट टॉपिक. टू स्क्वायर नंबर, two square number are there and with the same these are consecutive. Consecutive means they are continue. Suppose first number we are taking 2 square and this 3 square. 2 and 3 are continue, means consecutive, and the square of 2 is 2 2 ja 4. Square of 3 is 3 3 ja 9. Now see, between these two how many numbers are there? After 4 what is coming? 5, 6, 7 and 8. So how many numbers are there? 1, 2, 3, 4. 4 numbers are there between them. One more example I am taking. Suppose I am writing here 4 square and 5 square. These are continue, means consecutive number, and the square of these number are 4 4 ja 16, 5 5 ja 25. Let's see, after 16 what will come? 17, 18, 19, 20, 21, 22, 23, 24. 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers are there. Now, for this one formula we are going to form. How many non-square number are there between two square numbers? How many are there? Suppose this is n. We have taken here 2 and 3. This one we have taken 4 and 5. So next can we take here n and n plus 1. Next number will be plus 1 only, right? N and n plus 1. The square of n and square of n plus 1. So how many numbers are there between these? In this one, when you will see, there are 2n numbers. How many? 2n number. 2n means the small number, take the smaller one and just take double of the same. Now see, come back to the same example. 2 square and 3 square. Small number is 2, means this is n, and the double of 2 is 4. There are 4 number or not? 1, 2, 3, 4. Similarly, come back to this one. 4 square and 5 square. Smaller number is 4, means this is n. Double of 4 is 8. There are 8 number or not? 1, 2, 3, 4, 5, 6, 7, 8. So between two consecutive square numbers, there are 2n non-square number, right? Very easy. Now we will talk about Pythagorean triplet. Let's take new page. Pythagorean triplet. As we have learned in previous class, Pythagoras theorem. In Pythagoras theorem we are using in right angle triangles only. In right angle triangle you can see this one. hypotenuse, as we have learned in previous class also. This is base, and this one is perpendicular. Okay, so here we know that perpendicular square plus base square is equal to hypotenuse square. It means sum of square of two side is equal to square of third side, and that should be greater one, opposite of 90-degree angle, right? This is the Pythagoras theorem. Now for the same, suppose the side is, one is I have taken here, perpendicular is suppose 6, base is suppose 8, and hypotenuse what will come? So 6 square plus 8 square should be equal to 6 6 ja 36, 8 8 ja 64, so should be equal to 10 square, means 100. So this will be equal to 10 square, means 6, 8 and 10. In Pythagoras triplet, this should be always a greater than 1. Why greater than 1? Because less than 1, if you will take 0, triangle is not possible. So for that we will take greater. So for these Pythagorean triplets are, we will take 2n, n square minus 1 and n square plus 1. This greater one is hypotenuse, smaller one is one side, and n square minus 1 is other side. This is always hypotenuse. Now let's see this one. This one we have taken a 6. So first one means 2n is equal to 6, means n is equal to 3. When we will divide by 2, the value of n is 3. Now put this value in this one. We are just trying to prove this. So here 3 is equal to 2. So 3 is equal to n. So 2 multiply by 3, and here put the value of n, 3 square minus 1. Here also put the value of n, 3 square plus 1. 2 3 ja 6, 3 3 ja 9, 9 minus 1 equal 8, 3 3 ja 9, 9 plus 1 equal 10, 6, 8 and 10. See, this is same as it. This is Pythagorean triplet. So we can use this thing. So one example I am going to take here, how to find prime factor. Because for a perfect square, always whenever we are doing prime factor of a perfect square, it will be expressed in the product of pair of equal prime factor, always. Like one example I am taking, one is 225 is a perfect square or not. We will see. First find prime factor of the same. Is it divisible by 2? No. Is it divisible by 3? 5 plus 4 equal 9. Yes, this is divisible by 3. When we will divide, 3 7 ja 21 and 5 ja. Again divisible by 3. How much time it will go? 25. Now divisible by 5. 5 5 ja 25. Now by 5. 5 1 ja 5. Now see, this is equal to 3 multiply by 3 multiply by 5 multiply by 5. Right? Just before I told you, we can express as the product of pair of equal prime factor. This is one pair of equal prime factor, the second pair of equal prime factor. If these are not equal in pair, it means this is not a perfect square. Here we have, it means this is a perfect square. Right? Now we can take them back. 3 from here and 5 from here. 3 5 ja 15. What will come? 15. 15 is the square root of this. It means square root of 225 is equal to 15. This is the way to find square root also. So try to do. I'm just going to show you some questions. Try to solve them yourself. So here question number 1, 2 and 3 you may try to do in your copy. Some square numbers are there, then these are perfect or not. We have already learned in this video. So watch the video at least 2 times and see. If you didn't subscribe it and share with your friend. Thank you.